question 14. Now we have the wind. The wind can either add to the speed of the airplane, or the wind can subtract from the speed of the airplane. Because the airplane has a terminal speed, the fastest it can go in still air, but the wind can either add a little bit or take away from that. So what we've got on 14 is an airplane flies from Metro City to Gotham with a tailwind that increases its normal speed by 60. On the return trip, the plane must fly against the wind, which is going to decrease it by the same amount. So that's going to decrease it by 60. The flight from Metro City to Gotham takes 2.78 hours, and the return trip takes 4.17 hours. How far is it from Metro City to Gotham? So let's think about what we've got here. We're going to go from Metro City to Gotham, and then we're going to come back. Now we do have a wind, and the wind is 60. We're going to let x be the speed of the plane in still air. So that's the maximum that plane can go in still air. Now that wind can either add a little bit or subtract a little bit from it. And the wind, when we go, that wind is going to go in this direction. So when we're going to Gotham from Metro City, it's going to add. So when we go to Gotham from Metro City, it's going to add. So my rate, because this is my wind here, when we go there, my rate is going to be speed of the plane, which is x, plus 60. And then we have a time. The time, if we read it, the time from Metro City to Gotham takes 2.78 hours. So we have to have a rate, we have to have a time. So this is when we go from Metro City to Gotham. Now, when we come back, what's happening to this airplane? Well, when we come back, the wind is going in this direction. It's going to force it backwards, and so its rate is going to be x what? Minus 60, right? I should put the wind over here too, just so you can see. Here's your wind. Okay, your wind's going to either increase it or decrease it by 60. And since that wind is going to slow it down when it comes back, that's going to add a little bit of time to it, and that means my time coming back is 4.17 hours. Is everyone okay with that? So we see how this one's set up, right? The wind is either going to add to it or subtract from it. Now, what do we know about these distances? Well, if I'm going from Metro City to Gotham, that distance should always be the same, right? So in that case, these are going to do what? These are going to equal each other because those distances are the same. Now we can build our equation. And we'll just call this one 1 and this one 2. They should equal each other. And the distance equals the rate times the time. So on our first one, they're going to equal each other. Our first one, that's 2.78 times x plus 60. And our second one, well, that is 4.17 times x minus 60. Does everyone see where those came from? Right? We're just multiplying here, multiplying here. I'm going to go ahead and finish this one out. We've got a little bit of time. So I'm going to go ahead and finish this one out because this one actually wants the distance, not the time or not the rate of the speed of the airplane. It wants the distance. So let's go ahead and finish this one out. I'm going to distribute that 2.78 through and also the 4.17 through. So use a calculator, distribute through. So that's 2.78x. And then we've got 2.78 times that 60, and that's 166.8. On the other side, we have 4.17x. And then we've got a minus 250.2. Is everyone okay with that so far? So all we did was we distributed it through. Now I am working this one out because x is not going to be our answer. X is going to be the speed of this airplane. But that is not what we want. We want the distance. So we're going to have to find the x, and we're going to have to plug it back in to get the actual distance. So let's go ahead and solve this. I'm going to move that 166.8 over. And I'm going to move that 4.17x over as well. So 2.78 minus that 4.17. That gives you a minus 1.39x. Those can go. Those can go. And we've got 250.2. It's negative. We're going to add to that. Well, since they're the same, we're going to go together. 166.8. So those are the same signs. So that comes out to be a minus 417. Because those just go together. Okay, nothing new there. Now we're going to divide by that, a negative 1.39. And we know a negative over negative makes it positive. And x comes out to be 300. Now, if you stopped here, you would probably only get 3/4 of the credit. 300 is not what we want. So 300, what is the 300? 300 is x, and x, remember, is the plane speed. So this is the speed of the plane. Now, what we want at the end is we want the distance. So we have to find that distance. Now, distance is the rate times the time. And let's go back to the first one. Okay, on the first one, if we go back up and we look here, okay, our rate was x plus 60, and our time was 2.78. So that's going to be, when we plug in our 300, that's going to be 300 plus 60, and we're going to have to multiply that by 2.78, and so that's 360 times your 2.78, and that should tell us then how many miles it truly is. Which that comes out to be, if we round, it doesn't say specifically how far or how much to round, but we'll just round to the nearest mile. I think they probably rounded to the nearest 10 miles, but if we round to the nearest mile, it's going to be about 1,001 miles. So x was not your answer. It's not enough. We wanted to find the distance. How far is it actually from Gotham City, or sorry, from Metro City to Gotham? And we found x, which is the speed of the airplane. Then we plugged that back into the first one here. We plugged that x in, and we calculated our distance, and it came out to be about 1,001 miles. I think they probably rounded to 1,000. Which is close enough. You know, I used 1,001, they used 1,000. They just rounded a little bit more than I did. But I want to make sure we know how this one works, because there might be one like that on your exam. Okay, we've got a little bit of time left. I want to pick out a couple more of these to look at and to discuss. Let's look at, how about question, these are pretty simple. How about we look at question 16? This is a pretty easy one. Now, question 16, we're going to try to solve this. And when we solve these equations, remember there are three different outcomes that we can have. You can get a solution, and that's called conditional, meaning you get a number. You can get an infinite number of solutions, and that's when it's true, and that's an identity. Or it can be a false statement, and that's a contradiction. No solution. So let's look at 16. So this is what we're going to work on. We're going to work on question 16 here. And we're going to see if this is a contradiction, a conditional equation, or if it's an identity. And so the first thing we always have to do is we need to remove our parentheses. And so let's go ahead and distribute that 5 through to begin with. And when I distribute that 5 through, that gives me a 10x. And then I've got 31 times 5. That's a minus 155 when I distribute through. And that is then equal to 10x minus 155. Simple enough. What do we know? Are the sides the same? Yeah, they are, right? So since these are the same, bless you, what type of equation is this? This is an identity. And what's your solution going to be? All real numbers. Makes sense on that. So that's going to be all real numbers. Another one I want us to work through, just to make sure we're comfortable with this one. Let's look at 18. Okay, 18 is a literal equation, and that just means it's an equation that has more than one variable. And I have to tell you specifically what variable I want you to solve for. And in this case, we're going to be trying to solve this for the h. Now, this question is a literal equation, and we have to solve for a specific variable. So the first thing I do is I want to find that variable. I want to put a box around it so I can keep track of where it is. And so the only part that has an h in it is right here. So that 2 pi RH is right there. And my goal is going to be to get it by itself on the left. So I want to get that blue box by itself. And so that 2 pi r squared, well, that's going to go over. Okay, so I'm going to move that 2 pi r squared over. Now, to save a little bit of time, I'm going to go ahead and switch the sides around because I want the blue box on the left. And so that's going to be a 2 pi RH. And then on the right-hand side, we've got the S minus the 2 pi r squared. Okay, so all I did was I rewrote it, moved them over, and I'm at this point. Is everyone okay with that so far? So all I did was moved it over. I need to now get what variable by itself? Well, I need to now get the h right here by itself. And we always think in terms of opposites. So how does the 2, the pi, and the r relate to the h? Well, they relate to it by multiplication. And what's going to undo my multiplication here? Division. So let's divide both sides by 2 pi r. All I need to now do for my answer is just rewrite it. So we've got h, right, because those can cancel. And then what's the other side? We don't break it down. We don't reduce it. We leave it as it is. So the other side, the right-hand side, is simply going to be s minus 2 pi r squared, and that's going to be divided by 2 pi r. So all I did was solve for that variable h. I want us to try to do 2 more, and then I'm going to give you that take-home final, and I want to look at one of those questions on your take-home final. I want to make sure you know how to set it up correctly. So we'll do 2 more of these. The 2 I want to work on are going to be 20 and 21. I'm picking question 20 because of the square brackets and also the parentheses. So we use square brackets when we have multiple sets of parentheses. Now let's remember how I'd handle this question. It's not a difficult question, but we have to make sure we approach it in the correct way. We always work from the inside, and we slowly work our way out. And so on the inside, we need to go ahead and get rid of our parentheses so that 4 can be pushed through. And that's going to leave you then with a 2x plus 2 plus 4x plus 4. Right-hand side doesn't change. So it just gets copied. It just gets copied. And now, the square brackets work like parentheses, so we can combine some things together. I have a 2x, and I've got a 4x, so that makes it a 6x. We add them together. And I've got a 2, and I've got a 4 here. So when I add those together, that's going to make it a plus 6. And I still have my 5 out in front. And the right-hand side is still 3x minus 2. Simple enough. Distribute the 5 through, because remember, square brackets work just like parentheses. So that is now 30x plus 30 equals 3x minus 2. And we'll move things around to get what we want. So I'm going to move that 3x over so we can join the 30. There's x there, and I'm going to move the 30 over so we can join the negative 2. And watch your signs. So 30x minus 3x, that leaves you with a 27x. And on the right-hand side, we have a minus 2 and a minus 30, so that makes it a minus 32. We divide by our 27, and that leaves us with our final answer, which is then a minus 32 over 27, and that's not going to reduce down any. I really want to look at 21. I'm not going to do some of the others because we did a lot today with the quadratic formula. Like 22, 23, 24, those are quadratic formulas. We've done a lot of those. Write the number in standard form. We did a lot of those as well. So I'm not going to cover any of those. I think we've done enough of those. So let's look at question 21. And then I'll give you your take-home exam to help you study for the real exam. That's what it's all about, is doing well in the real exam. Now, question 21, we've got a 9x plus 9 quantity squared equals 4. What property would we use here? Can someone tell me what property we can use? Let's talk about the three that we have. Quadratic formula, square root property, zero factor. Which one? Which one does it look like we're going to be using? Yep, very good. Square root property. Okay. And how do I know it's going to be a square root property problem? Yep, because I've got the square. So that's the first thing I do is I identify it, and it tells me it's square root property. But that's how I know, is because that quantity is squared. Now, what undoes a square? It's the square root. And whenever I take a square root, that induces a plus or minus. So always remember that. The left-hand side is going to come out as a 9x plus 9. So that's done. The right-hand side, we still have a plus or minus. And what about 4? What's the square root of 4? 2. Now, we do have two separate equations. So there's two of them. So let's write each one out and solve it. So my first equation is 9x plus 9 equals 2. And my second equation is 9x plus 9 equals the negative 2. So one is a positive 2, one is a negative 2. You have to get both. And so I'm going to move the 9 over on our first one. And that gives you 9x equals a negative 7. We'll divide by our 9. And now we have it as x being a negative 7/9. Repeating the process on the other one, move the 9 over. 9x then equals a negative 11. Divide by your 9. And our second answer is x equals now negative 11/9. So we've got two solutions. And there they are. Okay, so let me go ahead and find, just had it a second ago, find your, there they are, find your take-home exam. It's worth 25 points. It's just designed to get you ready for the exam. I thought I saw it there. It's around here. And then there is one, there it is, that I want us to look at specifically. They're a little bit different on the questions, but similar. The practice one should help you work through the take-home and also the in-class one. So here's the take-home one. And one of them that I want to work through and set up is going to be question number 10, I believe. Okay, so question number 10. I want us to set up and talk about 10. I'm not going to work it out, but I'm going to get you mostly through it. I'm going to make sure you know how to set it up. And then you can solve it at the end. So on our our take-home exam, question 10. Chuck and Dana meet in Chicago for the weekend. Chuck travels 144 miles in the same time, very important there, same time Dana travels 124 miles. If Chuck's rate of travel is 5 miles per hour more than Dana's, and they travel the same length of time, at what speed does Chuck travel? So let's take a moment to think about what we've got. So we've got two individuals, and they're both going to be going to Chicago for the weekend. So we have Chuck And Chuck is going to Chicago, and I'll just make a dot here for Chicago, because they're going to be different places. There's Chicago. So Chuck is maybe coming from this way, going to Chicago. Now, Chuck travels a distance of 144. And then Dana, maybe she's coming from a different part of the state, and she's coming this direction. And Dana travels 124 miles. So that's what we've got. So different people going to Chicago. Now, what does it tell us in here that we have to be careful about? Okay, we've got our distances, which is a little bit different because normally we don't have the distances. And it says they travel the same length of time. So we're going to have to deal with that time in a moment. But it says Chuck's rate of speed is 5 miles per hour faster because he's traveling more in the same amount of time. So Chuck's rate of speed is going to be 5 miles an hour faster. Now we don't know Dana's rate of speed, so we're going to call Dana's rate of speed x. Unknown, we don't. And so that means that Chuck's rate of speed is going to be x plus 5, right? Okay. Now, this one is a little bit different, and this is why I wanted to set it up for you. What is the same? There's something that's the same, and it tells us, when we read this question, they travel the same length of time. So the times are the same. Very important. The times are going to be the same. How do we find time? Well, we know that the distance is going to equal the rate of speed times the time, right? Distance equals rate times time. Now, if I want to solve this for time, I just simply divide both sides by the rate. And now I get my time is the distance divided by the rate of speed. So that's our formula there. Time. Normally we don't do it like this. It's a little bit different. That's why I want to set this one up. Now, what do we know about the times? Very, very important. These times are the same. So let's talk about Chuck. Okay? Times are the same. That means Chuck's distance is what? Distance is 144. Okay, that's his distance. And what's his rate of speed? If we go back and we look, that's going to be x plus 5, isn't it? Right? Everybody with me so far? Now, what about Dana over here? Okay. Dana, that distance is 124 and an unknown rate of speed, x. We're going to have to cross multiply to solve this out. So we're going to go ahead and cross multiply, and that's going to give you 144x, and that's going to then equal 124 times x plus 5. And I think you can finish it from here. And you're going to have to solve it for x. And then find Chuck's rate of speed. Which will just mean we're going to have to add 5. So we'll find x. We want Chuck's rate of speed. He's 5 miles an hour faster. So we're going to just have to add 5. So that one was a little bit different. It's the only one like it. And I want to make sure you've seen a question like this. Now, when I make up your exam, it's going to have questions like the practice exam, questions like the take-home exam mixed together. They're all very similar, though. They're a little bit different, but most of it's staying the same. So that should now take care of the lecture for today. So I'm going to let you out a little bit early. You've got plenty of things to work on. Let's talk about what's due on Monday. So what's going to be due on Monday is your homework packet, 1.1 through that 1.4. So that's going to be due on Monday. You'll also get 5 points for completing that practice final. Also what's due is that take-home exam. And that's going to be worth 25 points. Make sure you turn that in as well. And then we're also going to have an in-class exam. Now, what can you have on your in-class exam? You can have a calculator. You can have either 1 page of notes, and that can be front and back, or you can have note cards. As many note cards as you think you need. So if you want to bring in 10, 15 note cards, you don't want to try to bring in 100. That'd be way too many. But, use your kind of judgment to figure out how many you think you need. Write up things like your common formulas. Like you might want to write up the quadratic formula on one side and then an example on the back. That might be a good thing to do. Zero factor, same thing. Square property, same thing. That way you have them all. Maybe you want to write down an example of the mixture ones or the investment ones. But you could have either 1 page of notes or a stack of note cards. And also make sure you bring in some scratch paper. So that's going to be what we're going to be doing on Monday. And I will see everyone then on Monday. And normally on exam days, we come in, we'll review that practice exam a little bit more if we need to. Then we'll take our exam, and that's normally about all that we do. It's hard to make sure that everyone gets it finished in time to start a new lecture. And if I start a new lecture at the beginning, then students aren't paying attention to that, and they lose focus on the exam. So normally on exam days, I know I hate to let us out that early, but on exam days, normally we come in, we take our exam, and that's it. So I will see everyone then on Monday.